most of us are familiar with the process of a web request. You start with a client. When you type a URL in a browser, it sends off a request to a server, which makes API calls, database calls, whatever you have it. It creates a response, and then it sends it back to the client, which then renders it to the browser, which is what you see. I'm, of course, hand-waving a lot here. It's very straightforward of a process, but the complexity lives in the server, right? Because there's so much that happens in order for that response to be created. You have to parse TCP so that you know how to handle those protocols. You need to parse the request itself, grab the headers, whatever metadata is associated. You need to route specific paths to specific handlers or controllers or what have you. You need to get data and so on and so forth. And so most of us use a framework when it comes to dealing with a lot of this. And Phoenix is a very popular one in this community that allows you to do all of this stuff. You can also reach for Erlang libraries like directly or Elixir libraries to do various pieces of this. So it's not necessary that you use a particular framework. But the idea holds that a lot of the server-side stuff happens within the tool chain of the Elixir ecosystem. And so just to illustrate this process, let's look at the request and a response as it goes through like an Elixir or a Phoenix cycle. So you start with a listener process. So that's usually Ranch or Thousand Island, depending on what you're using. If you're using current versions of Phoenix, you're probably using Bandit, which is using Thousand Island. Otherwise, you might use Cowboy, which uses Ranch. So the listener process is listening for any connections. So every time you make a request, it listens for that, and then it passes that on to whatever framework or whatever like server that you're using. And so either Cowboy or Bandit will then pass that along to various parts of your framework. So you have a router maybe, you might have controllers, you might have various handlers or helpers. And I like to call all of these just like the framework complexity. And that is the middleware and plugs and any other details that go into making that request create a response and making that possible. But before I dive into plugs further, I wanted to introduce myself. My name is Divya. I go by short div online. I work at fly.io, which is a company you may have heard of, maybe. And I actually spent the last summer, or this past summer, at a place called Recurse Center. So I took 12 weeks off, and I worked on like various projects from hardware to like software projects, actually mostly software projects. I did a bunch of metaprogramming. I wrote Raft in Elixir, which was pretty cool. And so if you're interested in that, come find me, because I have a lot to talk about when it comes to that. Or you can talk about Fly to me too, that's fine. And so to return to plugs, there's this idea of like a framework, or at least I kind of hand-waved a bit to be like, there's a framework and there's various things within it. But how does this work? Like, how does all of these work in concert to make a request, create a response, to make a response? And to understand that, I think it's useful for us to look into the HTTP server layer. So most of us use Phoenix, or maybe some of us use Phoenix, but Phoenix itself uses a specific server, so Bandit or Cowboy. And these are just tiny servers that are built in Erlang within the OTP system. And as I mentioned before, they use Ranch or Thousand Island. So Bandit uses Thousand Island, Cowboy uses Ranch. I guess there's a correlation metaphorically there. But they're both socket acceptors. So essentially, when you make a request, it takes that connection, it manages that TCP connection, and then passes it on. Of course, it doesn't make sense unless you see some code. So here's some code of how Cowboy looks like within an application.ex file. So you will see that we have a start process, which is on the bottom. And the start process is where you define a bunch of routes. So here I'm just defining a catch-all route with a handler that's defined on the top. So here it's like every single, like whatever you type into the URL will just give you a hello cowboy. And then there's a start process in which you add config, you can add environment variables, and of course you pass specific routes to that. So when you compile the routes, you pass that to the start process. And then Cowboy is able to do that dance. You can of course extrapolate certain pieces. You don't have to like have everything be in application.ex. So here I'm just like creating a separate file called web.handler, and that's still the catch-all, but I can also change it so that I can create specific routes. So here it's just like slash is a route handler, and then a route handler does stuff to it. And I'm just gonna look at the route handler code because the application file isn't very interesting. Because the handler is basically how a response gets created, right? So here we just have like a cowboy rec reply, you pass in a status, content types, whatever you want to do within that context. But of course, most of us aren't dealing with things at that simple a layer. We're doing a lot more to it. So here's one instance in which we're reading auth headers because we're gatekeeping, right? We want to make sure that certain people have access to certain content. So we're reading an auth header, and in Cowboy, you would do rec header and read the authorization piece. You would do some logic there in order to figure out whether someone should get access or not, and then you would render specific content appropriate to that access level. And so there's a bit of like verbosity here because you're directly writing to Cowboy like itself because it's a raw request that you're dealing with. And similarly, if you wanted to stream, because that's one other way in which you can send data to a process, is you would basically have to like create a reply and then you can stream a body through. And again, like what I'm trying to get at here is that when you're dealing with Cowboy, you're dealing with raw requests. You don't get the niceties of an abstraction layer because you're dealing with the manual like request itself. And so you're writing everything. And another thing to note here is that within Cowboy, you're passing the previous request to the next request because the state needs to be passed through so that it knows how to handle it because it's basically handling that particular stream of content. And so if I wanted to, I could extrapolate a lot of those pieces into like a abstraction layer, and this is what plugs gives you access to. So if you were to just, and this is just like a contrived example, but it is to just illustrate this idea that when you're dealing with Cowboy or you're dealing with an HTTP server directly, you don't have access to that abstraction of like dealing with things not at the raw level. And so here you have access to plug.con, which is a connection struct that the plug library gives you access to. And then within that, I can then update the connection or update that construct without me having to remember the state or pass that state through. I can just update it very nicely. And another way in which plugs are really nice is that if you remember from earlier, and you don't have to remember because I'm showing you code right now, you basically have access to this like handler, and you pass in a path, and you're like, here's a handler. But for each path, you basically have to like define a handler, and sure, you can extrapolate that into like a helper function and do various things. But the idea holds that when you're dealing with Cowboy, you're still like directly writing to that request, to that raw request. And so with plugs, you have the ability to extrapolate things into a router file, and then within that you can do things. So it doesn't make sense here, but just I will show you in a second. We're basically, instead of passing an empty array, we're passing a router to Cowboy, which then is able to like do various things. So here I have like two files next to each other. Maybe it'll make sense. But my router basically uses plug.router, which is like, it has some helper methods that gives me access to plug.con. It gives me access to various things that allows me to update that particular connection. So you'll see on the bottom page handler piece, I have that connection that I can then update a path, and then I can call a router with that particular con. So it's really nice. I don't have to like directly write the raw request every single time or remember what happened in a previous state. And there's also a way for me to create a pattern that's reusable across my code. So I talked about plug, but I wanted to just define it directly so that we're on the same page as to what it actually is. Plugs are just modules in Elixir that allows you to build things composably. So a plug, the responsibility of a plug is to intercept and modify a connection. So it basically takes a connection and modifies it, and then it passes it on. That's really what it does. That's all it does. And there's two ways in which you can use a plug in Elixir. There's function plugs and module plugs. They aren't much different, maybe just slightly, but a module plug is just an extension of a function plug. A function plug is just a function, so it takes a con and then it gives you back a con. But a module plug kind of has a different piece in which there's like a compile step and then a runtime step. So the compile step is the init function, so it defines an init, which is a single arity, and then it has a call function, which is a two arity, which then is run at runtime. So anytime you have a request, call gets called, and so on. And init is just when you set up options. So it basically is like when you pass options into a plug, it takes that, it like remembers it, and anytime it gets called, it runs. Easy enough. And so just so that we understand what a function plug is, a function plug, just to see the code and to see how it works, is that you have this idea of I'm going to create like a set custom header function, and then I'm going to use that within my router. So my router has like plug set custom header, and then it's just a single function that runs. And all it does is it takes that connection, and then it updates a header with a custom header. So like very straightforward. There's nothing crazy about this, but that's essentially what a function plug is. It's like within your router itself, you can define that and you can run it appropriately. A module plug is a little bit extra or a little bit different, but similar at the same time. The idea here is that it doesn't live in your router file, it can live in a separate file. And then you define it where you import a connection, and then you define those two functions. So you have your init, and then you have your call, and it does the same thing that your function plug does, except it's kind of like a bit different, or it looks a bit different. And then you would use it kind of similarly, but differently at the same time. So if you remember from earlier, you would do like plug colon whatever, which is like running the function. But here it's like, because it's a file, I'm basically just defining the file, and then it runs. A thing to note is that plug router automatically has the ability to run plugs. So like, I'm, again, hand-waving a little bit here. I'll show some code where things actually work, so maybe it'll make more sense. But the idea is that plug gets run for any route that's defined. So you'll see like the get is being defined with some controller logic, but the plug is run for that particular request, and so on. So the thing that is nice is that all of these things that tie together is this plug.con. Whether it's adding a header with a function plug or a module plug, they all implement this thing called con. And con, and something just to remember about that, is just a uniform way in which you can deal with a connection. So when we were dealing with things in Cowboy, we basically were not dealing with a unified request. We were sort of like modifying and changing it as it needed to be and then handing it off. But plug.con gives you specifications around how a connection looks like, what helper methods are associated with that, which then allows us to work with it much more easily. And now that we've established that plug.con is really important, plug.router is also really important, as I've shown like in the code itself, because plug.router gives you the ability for you to do things with your router code. So this is a very common pattern when you write routers in Elixir. You would basically use plug.router, which is one way in which it's a macro, and we'll talk about macros in a bit, but it gives you the ability to define certain plugs. So here I'm defining a match plug and a dispatch plug, and then it gives you the ability for those plugs to run with those routes defined. But the really cool thing about plug router is that that is a plug itself, which is kind of like meta in a way, which is, I think, kind of cool. And I'll show you exactly why. And this is kind of where we go in the weeds a little bit. Just like bear with me, it will make sense. So plug.router, this is just code that has been taken from the library. I sort of took like a piece of it. I didn't want to show all of it because there's so much. But you have this concept of using a plug builder. So what a plug builder is that it's a way for you to build plugs or build a plug pipeline, which is interesting, but it doesn't quite explain why plug.router is a plug. But it will make sense now, because plug.builder, if you look at that code, it basically has a macro, it defines a macro, where it defines an init and a call. So basically, plug.builder is a plug, and because plug.router uses plug.builder, it is a plug also. So it's kind of like multiple levels, turtles all the way down situation, which is kind of cool, I think. And so with this context, I think we can kind of make our own router because it's not that difficult, turns out, if you're willing to go on this journey. But it is a little bit complicated, but we'll walk through it. So I don't know how many of you have metaprogrammed in Elixir before, but I'll give you a little bit of a primer so that we aren't going in with blind. So here's a module called greetable, which is a macro. So I'm defining this particular greetable module. And so it basically has this macro called __ using. And what that does is it allows that function or whatever's defined there to be injected in any module that uses it. So if you look at the bottom part of the code, when there's English greeter and Spanish greeter, they both use greetable. And by using it, they're basically importing those functions defined in that module. And the functions that are defined in the quote do. So you'll see quote do has a def greet and a def farewell. So those are functions which will get injected into any module that uses that particular macro. I hope that makes sense. So if you were to run it, you'll have EnglishGreeter.greet, and you pass in the name Alice, it'll give you hello Alice. And if you do Spanish, it'll give you hola, because we're also passing in an opt, so it changes that. By default, it's hello, but for the Spanish, it's hola because languages. And so that's really nice. That's the idea of, in a nutshell, how metaprogramming works. So we will figure out how this works with plugs. With router, because it will make sense. And so the rules of plug, to remember as we're writing this, is that we have to implement an init that is single arity, and we have to implement a call which is double arity. And we also have to use plug.con, because that's a specification for plugs, very important. So I'm going to call my router spaghetti, because the code is spaghetti. I think there's a Western, a spaghetti Western in there somewhere, but anyway. We'll start with defining a def macro with __ using, and then we'll do the quote do, which basically implements an init and a call, because those two are very important for something to be a plug. So we're good. This is so far a plug that is usable. But it's not very, it doesn't exactly do what we need to do yet, because we need to import itself. So this is a little confusing, but bear with me. So you would think that if you imported a function in itself, it's self-referential, but it is not. Because if you remember, I mentioned quote do is anything that's injected into a thing that uses it. So a module that uses a router will basically have access to it. So whenever I import spaghetti.router, it basically is not the router importing itself. It's anything that uses that router importing that, if that makes sense. And then it implements a plug behavior, which is also a way of defining hey, this particular piece of code is a plug. And so to expand that macro a little bit so it makes a bit more sense, if I have a router and I use that spaghetti router, what happens here is the use macro will expand, and then it will basically be equivalent to importing and then creating calls or creating those function calls directly. So just niceties of metaprogramming, which are cool. But of course, it doesn't do anything. Our router doesn't do anything right now. It just is a plug, but that's cool. But it should do something. And so the thing with routers that is nice is that it gives you that get, post, put, various functionality. And so I'm going to define a get macro within the context of my router. And so within that, I can then make it do certain things. So here, I'm just defining a function called content4, which basically runs a controller, or it calls a controller with a certain action. And so what apply does here is that apply is a dynamic invocation. So it basically makes a call to a different function. So it's similar to kernel.apply if you've used it before, but the idea being that get, like whenever get is read, when the router basically is reading a thing, and it's like, hey, this get is being called, it takes the controller and then it basically like shells out a call. And that's like what's happening under the hood. And then within that kernel.apply, it takes in 3 arguments. It takes in a module, it takes in a function name, and it takes in arguments. So that's just like the function signature of how that works. But the idea is just pretty straightforward. It basically allows you to define a get with a controller and various things. Again, side-by-side comparison, because it doesn't make sense unless you see it. The middle piece is where we're using our router, and then we're defining our path. So we have a get with a slash path, and then we have a controller, and then we have some kind of function. And in this case, I call it home because slash is home. And so if I were to kind of correlate those 2 pieces of code, the router, the spaghetti router with our router, basically page controller is what gets applied. So it's the module that then gets called, and then the action is home, which you'll see below, which is the put rest body. So there's like various parts that has to happen in concert for all of this to work, but it works, I promise. And so I want to show you some code because, again, it doesn't make sense unless code is seen. I really hope this works because, okay. So, next run. Okay, I want to show you this first. It's very small. Okay, I hope you can see that, but this isn't much different than what I showed you earlier. Maybe just a little bit. There's like 1 extra piece and maybe 1 extra path. But the idea holds. We're using our spaghetti router, and then I have a page controller, and I can show you that too if you're interested. But the crux of it is that I'm defining a get, which basically calls some kind of home, and home renders a home page. And like, there's a lot of extra code here, but again, hand waving, but it will say like, howdy ElixirConf, if this works properly. That's not correct, but it does, it works, okay. So like, again, hand waving a little bit, but the idea is that you have a router file. This is not the right router file, but I will show you the spaghetti router file. So spaghetti router is like, you'll see the macro, you'll see the fact that it imports itself, and then there's a call to a content4, and then you'll see this get. So that's like what I showed you from before, nothing different. But yeah, it basically like implements it. So this is not using plug.router, this is using my router, so it's better. And so another thing that you can do, which is super cool, and this is like where it gets a little bit in the weeds, is that you can do more with that. So if you've dealt with like plug router or Phoenix router, there's like all this extra magic that happens. You might see scope, for example. Like, how does scope work? I don't know. Scope is a macro, it turns out. And so you can actually implement that as well. And like the code gets a bit more complex. And I will show you that. But basically, the idea is the same. We have a macro that we define, similar to get. So we have our get here. I'm adding some extra code, and I will not go into detail on how all of this works, because it is a little complex. But you basically have access to like a scope. So what scope does in my router example is that it gives me like scope/dev. and then within dev, there's a get hello. So the assumption here, I'll run it and then I'll explain the code, is that if I go to dev hello, it gives me howdy there, stranger, which is cool. But the idea is that it basically is running this particular macro, which defines the scope. So like it grabs the particular scope path and then it sort of injects it into the next get, and it puts it all together so you get this particular path. So if anyone is interested, I will share this code with you because like there's a lot. But I think the thing I wanted to get at here with all of this is that plugs are really cool, and like if you really dig deep, most of like Phoenix and a lot of libraries that you use and are familiar with actually implement plugs. And there's a lot you can do with that. And I will say one caveat, which is like metaprogramming can be not the best because it is very hard to debug. It's very hard to debug. And ChatGPT will not help you if you try. But it's really cool, and I hope that this like motivates you to like work on plugs and like build your own plug, maybe. And that's all I have. Thank you.